Okay, before we do anything serious, Motor Biscuit had a story this week about a YouTuber who's 3D printing a full-size Formula One car body. The whole thing. And then, because apparently that wasn't enough content, the plan is to drop a Mercedes V12 in it and drift it.
I love that the print is somehow the sensible half of that sentence. Printing a body shell at that scale is actually very doable now. Big format machines, panelize it, bond it, sand until your arms fall off. Drifting it with a V12 is where an engineer starts sweating.
See, my brain went straight to the seams. Every big cosplay prop I've ever done, the printing is the fun part, and then you spend 3 weekends with filler and a sanding block questioning your choices. Now imagine that, but the part has to survive lateral G forces.
The bodywork isn't structural, so honestly, it might survive fine, right up until the first spin into a wall, at which point he gets to test his spare parts pipeline, which, to be fair, is the one genuine advantage of printing your car. Reprint the wing, back on track.
All right, on to the actual show. Here's my read on this week. 3D printing moved closer to the body and closer to the battlefield at the same time. A hospital got cleared to print implants on site. Defense money is going after the qualification wall. And Florida reminded us that printed houses still have to survive contact with reality. The big one is Walter Reed getting the first ever FDA clearance for a point-of-care 3D printed implant. We've also got Renishaw taking a software swing at metal printing's most annoying problem, $9 million for defense qualification, a carbon fiber trick anyone with an FDM printer can steal, and that Florida house.
And I'll say up front, the Walter Reed story is the one I've been waiting years for someone to actually pull off. Point of care manufacturing has been a conference talk staple for a decade. Somebody finally got the paperwork through, and the paperwork was always the hard part.
So let's do it. The most important story this week isn't a printer. It's a piece of paper. 3D Printing Industry and 3dprint.com both covered it. Walter Reed National Military Medical Center got FDA pre-market clearance for a 3D printed titanium cranial plate. And the reason that's a headline isn't the plate. Printed titanium cranial plates have existed for years.
Right. The plate is old news. What's new is who's holding the clearance. Every printed implant you've heard of until now came from a medical device company, a manufacturer with a factory, a quality system, regulatory staff. The whole apparatus. Walter Reed is a hospital. The FDA just said a hospital can be the manufacturer.
Okay, quick pause for anyone who hasn't gone down the regulatory rabbit hole, because I hadn't until I started covering this beat. What does pre-market clearance actually mean? Because it's not the same as approval, right?
Not quite, and the distinction matters. Clearance is the FDA saying your device is substantially equivalent to something already on the market. You're not proving a brand new concept is safe from scratch. You're proving your version of a known thing is made properly and consistently, which sounds easier, and it is, but consistently is doing enormous work in that sentence when your factory floor is inside a hospital. Because think about what that actually requires. Powder handling and traceability, machine calibration logs, post-processing, heat treatment, cleaning, inspection, every single step documented and repeatable, run by hospital staff, audited like a factory. The printer is genuinely the easy part. You can buy a titanium powder bed machine off the shelf. You cannot buy a quality management system that survives an FDA audit.
And here's the why should I care, because I think it's genuinely huge. Cranial plates are patient-specific. This is a piece of your skull, shaped from your CT scan. Right now, that means the scan goes out to a manufacturer. They design it, print it, ship it back. That's weeks. For a trauma patient, weeks matter.
Weeks in a supply chain with a lot of handoffs where things can go sideways. Point of care collapses, all of that. Scan the patient Monday, print in the building, implant potentially within days. And there's a quieter benefit, right? The surgeon and the person making the implant can be in the same room. That feedback loop just doesn't exist when your manufacturer is 3 states away.
The first point of care institution ever framing. That's coming from the coverage, and I'll admit my old reporter instincts twitched a little. It's a single source claim until someone digs through the FDA database. But even if somebody finds an asterisk, the substance holds. A hospital is now cleared to make its own titanium implants.
Fair to flag, and I'll also say it makes sense that Walter Reed got here first. It's a military medical center. They have the budget. They have the institutional patience for a multi-year regulatory slog. And they have a patient population where cranial trauma is sadly not rare. Most community hospitals have none of those three things.
Which raises the question I keep circling. Does this actually spread? Or is this a one-off that only works inside the military health system? Because hospitals will print your implants is a very different future than one very well-funded hospital prints implants.
My honest answer, it spreads, but slowly and top-heavy. I lecture in a biomedical engineering department, and point of care is the thing students always assume already exists. They're shocked when I tell them the regulatory pathway was the missing piece. Well, now there's a precedent. Big academic medical centers, the VA network, major trauma centers, they'll follow. Your regional hospital, not this decade. They'll partner with someone who has the clearance rather than build their own.
There's also the liability puzzle, which I don't think anyone's fully worked out. If a device manufacturer's implant fails, you sue the manufacturer. If the hospital is the manufacturer, the hospital is holding all of it, the surgery and the part.
Yep. And that's exactly why the quality system is the whole story. Though the hospitals that do this will do it because their documentation is bulletproof, not despite the risk. But the precedent is set now, and precedents in regulated industries are like first ascents. The second climber always has an easier time. Genuinely, one of the biggest additive manufacturing stories of the year, and there isn't a printer launch anywhere in it.
Speaking of metal printing's unglamorous problems, Renishaw launched something called Libertas this week per 3D printing industry. It's software for their Renam 500 machines, and it goes after two things: downskin roughness and support structures. And Jordan, I could feel you perk up when I put this in the rundown.
Because this is the deeply unsexy stuff that actually determines whether metal printing makes money. Quick translation for anyone who lives in the plastic world: downskin is the underside of any overhanging surface in a powder bed. The laser is melting metal that's sitting on loose powder instead of solid material underneath. So it comes out rough, drossy, dimensionally sloppy. The traditional fix is supports. And metal supports aren't like your PLA supports that snap off. They're welded to the part. Removing them is machining, sawing, hours of hand finishing.
So this is basically the metal equivalent of what desktop people have been chasing for years. Tune your machine well enough that overhangs just print clean and you stop needing supports in the first place. Except when I dial in overhangs on my printer at home, the stakes are a Warhammer terrain piece, not a titanium bracket.
That's genuinely the right analogy, just with the difficulty cranked way up. In metal, you're modulating laser power and scan strategy on those downskin regions so the melt pool doesn't sink into the powder and the payoff compounds in ways that aren't obvious. Fewer supports isn't just less post-processing labor, it's less wasted powder, less machining time, and this is the sneaky one, better nesting. If parts don't need support clearance, you pack more of them into every build. Machine throughput goes up without touching the machine.
The honest caveat being that everything we know so far is Renishaw describing Renishaw's software. Nobody independent has put parts through it yet.
Sure, their claims, their launch materials. But I'll say this in their favor. Renishaw is a metrology company at heart. Measurement people tend to be careful about claims because their customers will absolutely measure the results. And the whole industry is moving this direction. Support reduction through smarter parameters is where the competitive fight is right now because it attacks cost per part, which is the number that decides whether metal additive manufacturing wins a job. The thing I'd want to see from anyone testing it is fatigue data on those downskin surfaces. Rough downskins aren't just ugly. Surface roughness is where fatigue cracks start. If the finish improvement is real, this matters for parts that vibrate for a living, not just parts that need to look nice.
All right, factory floor, and it's a defense-heavy week. Two stories. First one, America Makes announced the winners for something called Delta Qual 2.0. $9 million, 3 teams, led by ATI, Trusted Metal, and Auburn University, all aimed at cutting qualification bottlenecks for metal additive manufacturing in the defense industrial base. Jordan, this is your old world. Give me the plain language version of why the government is spending millions on paperwork?
because the paperwork is the product in a sense. Here's the situation. Qualification means proving statistically, exhaustively, that a material and process combination produces parts with known reliable properties. In traditional manufacturing, you qualify once and you're done for years. In additive manufacturing, historically, if you change the machine, the powder lot, sometimes even the machine's location, you're requalifying from scratch. That can be years and millions of dollars per material, per platform. The delta in Delta Qual is the tell. The idea is, instead of requalifying everything when something changes, you qualify the difference. Prove that machine B is equivalent to machine A within known bounds and inherit most of the original qualification. If that works, it's the difference between additive manufacturing scaling across the defense supply chain and additive manufacturing staying a boutique capability at a handful of primes.
It's the same wall we keep seeing everywhere regulated, honestly. Nuclear's been grinding at it with wire arc parts. Medical just spent our whole first segment on it. The physics of printing got solved years ago. The prove it in writing to a regulator part is where the whole industry is stuck in traffic.
That's the pattern of this entire era of additive manufacturing. Yeah, well, I lived the early version of it in industry. We'd print a beautiful part in a week and then spend 18 months proving we could print it again. I should note the 9 million and the team details are single source from the trade press so far, but America Makes announcing qualification programs is about as in character as news gets. This is literally what they exist for.
Story 2, and this one's got a verified core. NAMI, the National Additive Manufacturing and Innovation Company, which is 3D Systems joint venture in Saudi Arabia with Dassault, received a military manufacturing license from GAMI, the Saudi Military Industry Authority. TCT confirmed the license directly. So Saudi Arabia now has a licensed military additive manufacturer.
And this fits a strategy Saudi Arabia has been very open about. They want a domestic defense industrial base instead of importing everything, and additive manufacturing is a shortcut to that. You don't need 40 years of accumulated tooling and casting infrastructure. You need machines, powder, and, say it with me, qualification. A license from your own military authority is the regulatory on-ramp.
It's also an interesting move for 3D systems specifically. The Western additive manufacturing hardware companies have had a rough few years financially. A joint venture with sovereign wealth behind it, and now a defense license is a very different revenue picture than selling printers one at a time.
It's arguably the model going forward. Sell capability and partnership, not boxes. The wider signal is that defense additive manufacturing is going multipolar. It's not a US and Europe story anymore. 10 years from now, the map of who can print qualified military hardware looks very different from the map of who invented the technology. And weeks like this one are how that happens, quietly, license by license.
Okay, down to the bench, because this one's for everyone with a printer at home. Hackaday ran a piece this week on strengthening prints with what they call a carbon fiber epidermis. You take your finished FDM part, lay carbon fiber cloth over it with epoxy, and cure it into a composite skin. And the claim is you get a dramatic jump in strength and stiffness without any of the fancy composite tooling.
And unlike a lot of maker strength hacks, this one has real engineering underneath it. There's a reason it works so well. Stiffness comes disproportionately from material far from the center of the part. It's why an I-beam is an I-beam. A skin on the outer surface is putting your strongest material exactly where it does the most work. The print underneath basically becomes a core, like the foam in a surfboard, and the carbon does the heavy lifting.
Which reframes something I think a lot of us get backwards. When a functional print isn't strong enough, the instinct is crank the infill to 80%, add walls, print it again overnight, and you burn a spool making the middle of the part stronger, when the middle was never the problem.
Exactly backwards, yeah. Past a handful of perimeters, infill gives you rapidly diminishing returns. A single layer of cloth on the outside can outperform all of it for a fraction of the weight. It also quietly fixes FDM's dirtiest secret, layer adhesion. Prints fail along layer lines because that's the weak direction, and a continuous fiber skin bridges right across them.
I did the poor man's version of this once on a shelf bracket that kept cracking. Fiberglass cloth and epoxy because carbon scared me. Ugly as sin, still holding years later. What's the real catch here? Because working with epoxy and carbon at the kitchen table sounds like a story that ends badly.
The catch is entirely in the handling, not the concept. Epoxy wants ventilation and nitrile gloves, always. Carbon cloth frays and shifts while you wet it out, so simple convex shapes are easy, and anything with tight inside corners will fight you. And the big one, if you sand cured carbon fiber, that dust is genuinely nasty, conductive, abrasive, terrible for lungs and electronics alike. Respirator on and nowhere near your printer. Your fiberglass instinct was actually the right call for a first attempt. Same technique, cheaper, more forgiving.
Worth saying Hackaday's piece doesn't come with test numbers, no before and after data on exactly how much stronger. But the underlying principle is textbook composites. So I'm comfortable calling this one real even without a chart. Time for the Is This Real segment, and this week's has a twist. The New York Post covered a Florida city breaking ground on its first 3D printed home. And the article's whole angle is experts calling the technology all hype, questioning cost, scalability, viability. So, Jordan, weird position for you. The mainstream press did your job. Are you out of work?
Here's the thing, though. Lazy skepticism bothers me almost as much as lazy hype. It's the same failure, just pointed it the other way. All hype is doing exactly what Homes in 24 Hours does, flattening a complicated picture into a headline. So let me try to be actually precise about construction printing, because both extremes are wrong. What the printer does is walls. That's it. Foundation, roof, plumbing, electrical, windows, finishes, all conventional, all still there. And the wall structure is a modest slice of a home's total cost. So printing was never going to slash house prices in half. The math doesn't reach that far. But walls only isn't nothing either. There are real completed developments now. Icons built a whole neighborhood in Texas. Leonard put actual buyers in those homes. People live in these things. That's past the demo stage.
And I have to flag the sourcing problem with this one, because it's the kind of piece my journalism brain distrusts on structure alone. Who are the experts? Are they reacting to this Florida project's actual numbers, or giving general quotes about a sector? From what I can see, the groundbreaking is a hook and the skepticism is generic. It could have been written about any printed home project in the last 5 years.
Which is exactly the tell. Real criticism cites numbers. This project's cost per square foot versus local stick frame construction, the schedule, the labor hours. Experts question viability with no data. Is Vibes wearing a lab coat? And I say that as the person whose entire brand is questioning viability.
So where do you actually land? Because I'll confess, construction printing is one where my optimism has taken damage over the years. The demos are a decade old at this point, and it's still, a rounding error of housing starts?
My honest position, it's a real technology stuck in a real niche, and the niche might be fine, where it plausibly earns its keep. Hurricane-prone areas, which, hello, Florida, printed concrete walls are monolithic. No framing to peel apart in high wind, and insurers may eventually care about that. Places with genuine construction labor shortages, that's a business. It's just not the end of the housing crisis business the hype promised.
So the verdict is basically the hype was wrong, and all hype is also wrong. And the boring truth is a niche wall building method slowly proving itself one subdivision at a time.
The boring truth usually is the truth. If a Florida city wants to spend its own money finding out whether the niche is real, that's not hype. That's the experiment actually running. Judge it in 18 months on cost and how the thing holds up through a storm season, not on groundbreaking day. That goes for the boosters in the Post.
Which brings us to your one thing to try this week, and it's straight out of that Hackaday story. Got a functional print that keeps failing, a bracket, a mount, a tool holder. Before you reprint it at heroic infill, grab some cloth and epoxy and give it a composite skin. Do what I accidentally did right, start with fiberglass. Cheaper, safer to sand, same principle, and you'll learn the wet out technique on something forgiving.
2 tips from someone who's ruined a few parts learning this. Scuff the print with coarse sandpaper first. Epoxy grips a rough surface and peels off a glossy one. So surface prep is 90% of the outcome. and do it on a sacrificial part before the one you care about, because your first wet out will be lumpy. Everyone's is. Gloves and ventilation, non-negotiable.
Lumpy but strong. Honestly, a decent motto for this whole hobby. That's the week. A hospital that's now a factory, software chasing supports, and a house in Florida with something to prove. If you skin a part, send us the ugly photos. We love those. Take care of your nozzles, and we'll talk next week.